Based on some questions I've been getting through email, I wanted to go over what a standardization curve is and why we would use one and what it can tell us. So in this case, I'm going to use the context for the lab that I was making this video for, which is Beer's Law. But in case people see this in the future, you could use this to think through any particular standardization curve. So in the case of Beer's Law, our idea is that we have, my drawing work, we've got a cuvette. It's got some solution in it. We're going to shoot a light through it, and then we have a detector. So the light hits the solution. Some of the particles inside of here, these, if we're going to use Beer's Law, some of them are going to absorb light. And so, if they absorb some of it, less of the light comes through and reaches this detector. So our detector tells us how much light gets through and how much is absorbed. So we want to know how much light is absorbed. And the idea would be that as you add more particles, more light gets absorbed. And if you have fewer particles, less gets absorbed. And so what we can do is we can figure out how much of whatever particle we're looking at is present in our sample based on the amount of light that gets through. Now this assumes that, for example, you don't have any other competing particles that could also absorb the light that would interfere with things. If your concentration was too high, it would cause the molecules to interact with each other, and then it would cause problems because that would change some of the properties and change its absorbance. But assuming you have a sufficiently dilute sample and that you don't have other particles absorbing, or if you do, you can subtract them out from, like, for example, the water. If you're doing this in a water solution, water absorbs, you would have a blank where you've already subtracted out all the absorption from water and you're just looking at your sample. So how do we do this and what are we going to do with it? So here I've got an Excel spreadsheet. Idea is, let's say we took a solution that we knew the concentration of, and we measured its absorbance, and I'll zoom in a little bit more, at 5 different concentrations. Now, these are not exactly evenly spaced. You could pick different concentrations. The idea was, though, is that, for example, let's say I looked at between 0.0. I'm going to add an extra 0 to these. I was missing a 0 on these. Because some of these, the concentrations are definitely too high. It would have caused an issue. So eventually, as your concentration gets above 0.01 molar, you start to have issues of things being too concentrated. It gets hard to use Beer's Law. But for other things, that would be fine. So let's say we have these 5 concentrations, and we've got these 5 absorbance measurements we've made. Now what we can do is we can make a graph of them. So I'm just going to highlight these 2, make a graph with a scatter plot. So here, if we label our axes correctly, our x-axis right here is the concentration of our solution. The y-axis is the absorbance. The concentration is molarity. We don't have a unit for our absorbance there that we're worried about. So what I want to do is I want to make a trend line here. So this is the idea behind a standard curve. It tells us what is the relationship between your x and y variables. So in this case, as concentration increases, how much does absorbance increase? For this particular property that we're using a standardization curve for, we are assuming it's a linear relationship, which is what Beer's Law would suggest is true. So I'm going to add a trend line. When I do this, I'm going to use a linear trend line, and I'm going to put my equation in my r squared on my chart. So my r squared is very close to 1. That suggests that this data looks very linear. As you get closer to 1, that means your data is increasingly linear. And this equation up here at the top is an equation where x is my concentration and y is my absorbance. So the reason this is useful now is now we've done this with a set of known concentrations. So we can make another measurement. Let's say I take an unknown. I don't know its concentration. But I find its absorbance is, let's say we got something with an absorbance of 0.324. What we can do is we can plug that 0.324 in for y, because y represents absorbance. You then solve for x. So I would add the y-intercept there to both sides. Then I would divide by 129.93, and that would give me my value for the concentration of that sample. And again, that's assuming the sample only contains this molecule that absorbs. Also, specifically for Beer's Law, this is done at a specific wavelength because the amount of light that something absorbs is going to change at different wavelengths. So that's our goal, is we need a set of concentrations that we know, so we can find those absorbances. In this case, I chose 5 points. And the idea is that this curve we generated, or not, it's not a curve, it's a line, right? We added a trend line. That trend line tells us what is the relationship between concentration and absorbance. And so then we could use that for any unknown sample to plug in that absorbance, then figure out what was the concentration of that unknown. And that's the idea of a standardization curve. Standardization curves are, okay, we've used a standard, and so now in our standard, we know these are different values we would expect it to take based on these different concentrations. So then we can plug in the thing that we can easily measure, absorbance, and then determine a concentration from that.